let's get started. I would like to introduce Kaizen's own Chelsea Jewell.
Thanks, William, and thanks everybody for joining us today. As he mentioned, my name is Chelsea Jewell, and I'm the Application Lab Manager for Kaizen's headquarters here in Nashville. And today we're going to talk about vacuum degreasing, and more specifically, is vacuum degreasing right for your parts? So just going to a brief overview, let's start with what is vacuum degreasing for those of you who aren't familiar with the process. So vacuum degreasing is a cleaning process using a single solvent. Typically, the working chamber will have either spray and air, spray under immersion, or ultrasonics. A lot of times the machines are equipped with all of these. It's also a batch style process. So when we say batch, we mean that all of the parts go into a single chamber and your wash, rinse, and dry steps are performed in that chamber as well. So here's a brief outline of kind of what happens within a vacuum degreasing machine. In the center, you'll see the work chamber. So this is, what we were showing in the previous slide, where your parts are placed in a basket into this work chamber, and this is where all of the cleaning and the entire process takes place. You'll see above the working chamber, there's 3 different tanks. So these are where the solvent is stored. Initially, when you start a process, your solvent from tank 1 will transfer into the working chamber. This is, think of it as a pre-wash. So your soil, the majority of your soils will come off in this first wash. From there, that goes through a pump and it goes through a filtration system. You also see an offline system that's going through tank 1 and pulling it over to our still. So this system has a distillation column that's constantly pulling solvent from that first tank and running it through distillation to separate out the different soils. The oil will transfer into your oil separator, and then from there, the hot vapors will actually carry over, go through a condenser, and be redeposited into tank 3. As tank 3 starts to fill up, it will cascade over into tank 1 and tank 2 to help replenish that solvent. So once your pre-wash is done with tank 1, tank 2 will normally move solvent into it, and that's a cleaner solvent to help rinse the parts and move on to your next step. Some machines will have a 3-tank system, some only have 2. It depends on how everything is set up. And then this all is kept under vacuum while it's cleaning. So let's talk about advantages of vacuum degreasing. So it's a closed loop system. The awesome part about this is if you have space constrictions, you can put this machine anywhere in the plant. You don't have to account for running water or a drainage system into it. Typically all they need is compressed air and electricity. We talked about the distillation system. So there is an internal soil management for each of these machines that's helping pull the soil out of the solvent and keep the system clean. There's a single cleaning material. So within that, all you need is to charge up the system with that single solvent, whether it's a hydrocarbon or modified alcohol, depending on how the machine is set up. And so you don't have to worry about any type of dilutions or concentration measurements. And the parts are dry at the end of the process. Once a little fine tuning is done to ensure this, with the help of the vacuum pulling all the solvent out and the heat from the vapors going into the process, this will help clean everything up and make sure it's dry at the end. So a lot of times when I get projects into the lab, the first question is really, what are the cleanliness requirements for those parts? Is it visual? Are we just looking at the surface removal? Are we getting into particulate quantities? Anything like that. So we're moving into, if it's just a visual clean, a lot of times, that's a Dines test that we're looking at. Just surface oil, that can be further testing with IC or any of those materials. Also, we're looking at particulate quantities. So these, if we're looking at millipore or counting particulates, these systems have onboard filtrations. So you're able to choose which filtration level you'd like, and you have less of a chance that the particles will redepose in the system as it's filtered out. Next, we get into part geometry. Vacuum degreasing is used, across military, aerospace, automotive, medical, because it is such a critical cleaning application. When you have blind apertures or tapped apertures, a lot of during that manufacturing process, chips and fines get trapped in those apertures, and it's very difficult to move them out. If you have narrow tubes, that have bends in them, cavities in cast parts, all these part geometries can cause issues with getting cleaning materials into those. With the vacuum degreasing system, you can, within the process, you can build in times where it will pull a vacuum to help drive the solvent into those apertures and then break the vacuum to drive it back out. So pulling and breaking the vacuum helps pull those chips and fines out of those areas. And then when you get into nested parts, a lot of times we see, with stamped parts, it's the same part. So you have a chance that they can start to collect or nest together. And once you get into a cleaning process, if those parts are nested together, it's very difficult to pull them apart and get everything, all the soils and everything in there back out. With vacuum degreasing, that chamber is constantly moving, and you have the vacuum to help drive the solvent into those areas and break those parts apart. Also, the basket rotates. Depending on how you set up your process, you can have the basket either fully rotate or oscillate back and forth depending on the surface sensitivity of those parts. And this, because of how everything rotates and moves, the multiple spray bars that are in the machine, it really helps prevent shadowing if we have any issues, with a certain area of a part, to drive the solvent through it. Then soil types. This is probably the most important when it comes to matching up your cleaning process. Most of the solvents that we use are very effective on the common industrial soils. So this will include oils, greases, and pretty much all of your non-polar soils. What we look at initially is solvency. It's looking at the boiling point of this soil and seeing how they match up within the solvent. One thing we found is, if you're looking at remanufactured parts or there's a layer of burnt carbon, it can be difficult to remove in this system. So we'll use a vacuum degreaser to remove most of your surface oils, greases, and then have a follow-up process for any type of burned carbon or any issues that you have there. So in these images, we kind of show normal cleaning results for this process. Initially, you can see with these brass parts, there's a high level of soil, there's a high level of chips and fines. These are fully open, so there's not any blind apertures, but you do have that tube effect that you have to be able to pull the cleaning solution through. After processing, you can see the parts are dry. You don't see any spotting or issues with that. And from what we can see, the majority of the chips and fines have been removed at this process. So like we talked about, the rotation of the basket helps drive that out, but also that solvent's then being pulled through a filtration system, so the fines aren't continuing and going back through your spray bars or anything that could redepose on the surface. So challenges when it comes to vacuum degreasing. First and foremost is the chamber size. Most of your production rates will determine the size of the machine. I've seen these machines have a 4-basket system. I've seen them have an 8-basket system. It really just depends on your production rates and what you're looking to pass through the machines. Typically, the cycles are fairly short. So you just have to help with your engineers when you're picking out the size of the machine with your production rates to help alleviate that, so it's not your pinch point. And then soils with low boiling points. What will happen if the soil isn't matched up well with the solvent is in that distillation system, rather than it distilling just the solvent out and it crossing over back into the tanks to be moved back between them, um, the soil will transfer over with the solvent, and that can cause some issues with cleanliness later on. So that's something we can definitely help you out with. Take a look at a soil if you have questions there. And kind of in summary, vacuum degreasing is a reliable, repeatable process because of how the machines are set up. It's the same process over and over. You don't see any variability as long as you're maintaining the system. It's always going to move the same amount. You're always going to see the same amount of time. So they're great for precision applications and repeatability. And then the process can definitely remove a broad range of soils, and its challenging parts are kind of where it excels, I feel like, with the vacuum and a little bit of tailoring to the process. And it's also, as we mentioned, these systems are able to run a high volume of parts because the cycles are a little bit shorter than what we typically see in other processes, and the parts come out dry. So at that point, you're able to move them on to the next step of the process. And with that, thanks, guys.
Thank you, Chelsea. If you'd like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, have a great day.